With the intro. Hello, everyone. I hope you're here for the digital twin session. Yay! Yeah. Hello, and welcome to another session for the Spanish TED Week 2024. This is Symposium 06. Yep, sound okay? Or? Yep, okay. Biodiversity data standards and fair in prototyping biodiversity digital twins. My name is Sharif. I'm one of your moderator, and I also have my co-organizers Dmitry and Kate here helping me. And of course, as you all know, this year's meeting was made possible in part by the generosity of our sponsors, especially our diamond sponsors, and we're grateful to them. And big applause to our help with the technical stuff for the OK Congress. Thank you. And this session will be recorded, so you can find it in the Oxford Abstract and also in the YouTube channel. And yeah, you know the instructions. Please speak slowly. Please try to keep the time in mind. You'll get a reminder from Kate, so we have enough time for question and answer and discussions. And there's a timer here for you to keep track of. And if you're attending online, please ask questions in the chat feature. I will look at that and present it here as well. So, without further ado, I'm delighted to introduce our first speaker, Dmitry Schigel from GBIF Secretariat.
Thank you. Thank you. TED Week has two phases. People develop standards, sometimes late in the night, in the pubs, with a cup of coffee or something stronger, and then there is a project show. So this belongs to the project show part. So I think it is an important phase of TED Week because we need to kind of showcase the work we're doing, the projects, and like the hardcore TEDwegian dislike that part. Like they want extensions, controlled vocabulary, but I think they work very nice together. So in my talk, I will introduce you yet another project. Like this is quite similar to the bicycle sessions that we had the other day, where there is a lot of biodiversity data progress is fueled by particular project idea, particular project funding. So this is what will happen here. Biodiversity Digital Twin project is funded through Horizon, European Union funding, and the idea kind of between the lines of the formal project description was that Finland built a supercomputer and they wanted to keep it very busy with something complex. And then they thought, maybe biodiversity can make it steam and smoke. And so, but then if you just put data on the supercomputer, not much is happening. So it was mixed with some modeling in the attempt to develop something that can mimic nature processes in a near-realistic way. My inner biologist is very skeptical about that. I think it's very utopian, but my kind of technology lover loves the idea because this allows us to test the limits of what we can do with the tech we have now. And I think if we see this prototyping project in that light, it becomes less sort of disappointing or less provocative as it may look in the beginning. So three objectives: deploy prototypes of biodiversity digital twin for addressing biodiversity dynamics. As you can see, this is not a map of world biodiversity, and European funding requires European Union relevance, so it's not kind of very GBIF thing to do, actually, to work in the EU-centric way, but the GBIF participation in this project was only possible because the executive committee realized that the solutions we are building, or prototyping rather, they are applicable worldwide. And so we are, if you're testing the limits of tech, it doesn't matter where you are. And then there are some high-level ambition to kind of make sure that all these solutions don't just die with the project, but they are integrated in certain super infrastructures in the EU. Small font, but you might recognize some familiar names on the right columns. Doug Anderson is online, Tomas is here, Sharif is here, and I'm here too. And so we basically participate in this project to see how much our research infrastructure work, our biodiversity data work can benefit from this project. This is the partners. I find this a bit overwhelming. Consortium project of 22 organizations is difficult to manage, but luckily we are not managing it. We're just running work packages. So, and it sort of actually works in a nice way. I didn't know what digital twin was before Hanna Koivula. Many of you here know her, called me and said like, hey, there is that thing, digital twin. Do you want to be part of it? And I said, what? And so I had to Google. And so this is the slide to save you some search in the internet. This is the industry-born concept. I know, for instance, like it's used in aviation. You can make a digital twin of a future airplane and test some aerodynamic parameters. It can be used in the pharma. You can have a very dynamic, very complex model of human blood. And testing drugs on humans is unethical, so you can do it digitally and to kind of for obvious benefits. So we would like to build something similar for certain aspects of biodiversity. So don't expect comprehensive here. So we have data, we have model and modelers, and we have users in mind. Some of them are real, some of them are imaginary. And then we have supercomputer to kind of cook it to palatable result. And yeah, so I guess it's actually not that innovative if you think about this, because this is this good old biodiversity modeling or niche modeling, but done in a dynamic way. Because most of the modeling still now ends up in the publication, static. There may be a software solution behind or a piece of code, but Twin is supposed to be dynamic. So as data grow and as model develops, your prediction things should change under your fingertips. This is the dream, at least. So this is a repetition, and it should mimic behavior observed in nature and meet requirements of use cases. And the use cases are actually quite important here. When we were designing and writing this project, we wanted to move from the top left to the bottom right. This is the increasing complexity of biodiversity data. This is also the gradient from fundamental research to more applied and kind of human-oriented aspects of biodiversity. And then policy concern, we have invasive alien species, and we have a particular chapter of experimenting with DNA-derived biodiversity data. A screenshot of the interface. The project is approximately 70% or 70% ready, so we have a bit less than 1 year to go, and the prototypes will be available for feedback. In fact, they are available already in the current state through Pensoft Rio publications. The data people, they're represented by Disco, LifeWatch, Elter, and by GBIF, and but we work in kind of different capacity with LifeWatch and with Disco. We largely develop the infrastructure solutions. I have a big dream bridging Elter and GBIF data, and this is mainly Kate Ingelnov's work line. We work on this together, of course, and we all know that Darwin Core was started by the museum people. And
Please, can you speak to the mic?
yes,
Nobody can hear you.
is this better?
Yeah.
Okay, sorry. Thank you, thank you. So yes, and connecting ecology to the world of Darwin Core is an old Tadwig dream, and we're doing much better already with DNA-derived data, but there is still a huge amount of work to do with Elter, with EDI, with NEON, and large and small holders of the ecology data sets. And but actually with Elter, we have concrete lines of interaction that we hope to utilize for that purpose. Again, so in this case, project is an instrument to achieve something that we wanted to do for many years. Things can happen naturally, but you know, Tadwig is a community of volunteers, and money has a disciplining effect, and projects have timelines. So that is what we hope here, that it will help us to, you know, put our marbles together and have a working solution. This is a GBIF slide showing what we do. There are data holders on the left and data users on the right. So we basically move through the same picture, and I just mentioned the ecology and monitoring data from the left side, and Twin belong to the right, somewhere in between sciencey things in magenta and policy things in blue. Yeah, the target groups and the audiences, like I think it will be fair to say that this is a project which has a lot of inward, internal beneficiaries. We're basically doing it for ourselves, for the partner organizations, but a little bit also for the outsiders and policymakers and the private actors are there. Civil society and citizen sciences as well. One of the more advanced prototype digital twin is on a honeybee, and there is a very active beekeeper community in Germany where the interest of this solution is very high. So this is another dream slide, what will be possible to do, and maybe some prototypes will actually deliver that. Maybe some of them will only showcase the problems and the shortcomings of the data or the modeling, which is also very useful. So we want to have prototypes ready, and we want to document lessons learned and exit the project where it stops. It's impossible to finish building biodiversity digital twin, but we'll have to stop doing that at some point in the middle of 2025. So that date will cover our stories and publications, improve community engagements, deploy the remaining PDTs. We have 1 deployed and 9 to go. And the FAIR principles are central and very important to what we do. It was very, very interesting for me as a coordinator of the data flows tasks to see how many different understandings of FAIR there are. From the people you think that, okay, obviously you heard it so many times, but then when you look at the actual implementation, huge, huge differences. And FAIR is also in the center of the work package 5, which is led by Sharif. Yes, and sustainability plan. So it's not just, historical monument to our 3 years long efforts, but they actually implemented in something that works. You can read about this in Pens of Trio. We published 10 PDT project papers covering each of the use case stories in reasonable level of detail. These are not papers describing the twins as they are, but describing the state of the project work at the 67% stage. So we do it 1 year too early to attract feedback, and we hope that the Tadwig Spinach audience will be people reading the paper and sending us feedback, or you can use very advanced Pensoft Rio technology and do comments actually through the Pensoft interfaces. So on purpose, I kept it very light, just to explain the basics. The actual content of this session is in the talks of the other speakers. Thank you.
We have time for maybe a couple questions. Yes, please.
Hello, I'm major in agriculture technology. I want to, because in my field, you are building an Earth in silica, yeah, a planet in your computer to calculate everything. And I wonder, I'm curious about if you are planning to add some agricultural model, for example, like DigSet or DNDC, to calculate how agriculture and diversity, or even the dynamic of the soil.
Yes, thank you. The acronyms you mentioned, I have no idea what they stand for, and probably never will. But the good news is that there is Agrobiodiversity digital twin about the crop wild relative in Ethiopia. So there is a crop which is used in emergency when there are droughts, and it has high toxicity, and there is some idea that it could be modeled for better. So there is a digital solution before agro-technology solution. Please come in the end of the session. I will point you to the right people who have actual answers to what you ask. Thank you.
Claus will talk about that.
Yes. Yes. Sharif, there is a hand? Yes.
Hello, I'm Anne from Finland. You had one call to sort of that policymakers would adapt this or
Yes.
use this information in the decision making. Do you have any plan how to sell it to?
There are 2 levels of this. So one is kind of local when we interact with the data holding community. Some of them have local level linkages to decision makers, like the honeybee model I mentioned. In Germany, at the country level, there are interactions, and it is done through an event when these things are introduced, and there is some exchange But the big requirement from the EU that these solutions are included in this Destination Earth and other European level infrastructures when they will be offered to the decision makers. And invasive alien species, I think, is one use case where this is actually a very, very strong connection, non-imaginary, but real connection to decision making.
Okay.
Yeah.
Good luck.
Thank you. Yeah. I know.
In the common atmosphere, it's not perhaps that easy to sell.
Yes, but I guess the general trend is to shift from the expert-based policy to data-intensive policy and decision-making. So this is part of the same story. It's not the magic fix to everything in science policy and data interface, but it's one of the little steps in this direction.
Yeah,
Thank you.
good luck.
Thank you. So you got the overall introduction to the project. So now, as Dmitry mentioned, we'll get into some details. So Tomas will talk about some prototype and show you some graphical user interface. Yeah.
I just want to say this session is being live streamed over V67, so we will see you.
Yeah. Okay. Thank you.
We're watching.
So thank you, Sharif. Shall I just go on? This doesn't seem like mine's. Yeah. Thank you. Thank you very much. So I'm Tomas Martinovic. I'm totally new here. I came from the IT, and when they invited us to BioDT project, I had no idea what we are going into, to be honest. I was wondering about some of the problems that I thought are very easy to fix, and then realized they are not so easy to fix during this time. Anyway, one of the things I was thinking about is when I go here. So when we were talking about the digital twin, we said, okay, we have this data, we have the models, and also we are thinking, okay, how to interact with the outputs, or how do we present these digital twins to the users? Should I go more? Yeah. So we were thinking about these things, and we were saying, okay, we will do some interfaces. At the first, to be honest, we didn't know what these interfaces will be. We were like, there are totally different people. Some of them are programming, some of them are totally not wanting to program. And we need to somehow cater to at least most of them. So that was the idea where we came in. And we kind of brought this idea of graphical user interface for the digital twins. As you know, we were saying we have a lot of prototype digital twins. There are a lot of use cases. At the time it was use cases, now they are prototype digital twins. And we are like, okay, we cannot create, graphical user interface for each of them. It's just impossible, at least like separate thing, because that's just too much in one project, and we didn't have that much effort for this task. And everybody also has different requirements, what they want. Some of them, are very easy to cater. Okay, just give us some interactive map that can have some pre-computed values or whatever, and everything is free, so everything is fine. Some of them we have very sensitive values, data, and yet not everybody can get to them. So we need to figure out how to store this data in a way that they will be safe and nobody can get to them. And others were like, yeah, and we need so people will be able to launch these models. And then we come and the HPC comes into the mix. What's not really the thing that users can use normally. It's actually to be able to use HPC. The classical way is that you use the SSH, you log into the terminal, and you are working just, with this terminal that are pretty much a text, and you are using text commands to interact with the thing. And that is not very user-friendly, and of course, no policymaker would use that. So then there came some tools that are creating to alleviate these problems, and we had to find a way how to make the interfaces for them. to get to that, before that, one of the other things that came into the mix was also these things that we want things fair. And, we want the fair data, we want to know where they come, we want to know when you create the data somehow to describe them. And I'm not going into this deeply because it will be presented later. But for us, the important thing was also we will have these executions, and we would like to probably also these executions to describe somehow if possible. And that's one of the things we are solving at our part. And now the thing that we decided upon, as I was saying, it was that we have these like 10 prototype digital twins, and we were, okay, most of the people are working in R, some of them know how to do the Shiny app, so let's do this very big mega Shiny app for each of those. We had some knowledge of how to make the Shiny apps before, we knew how to make some kind of, I would say, production kind of ready Shiny apps, so we started working on that. For those who don't know what the Shiny app is, so it is the web application that is written in R, the statistical language. On background, there is this classical HTML, JavaScript things that are the things you are interacting with when you are on the internet. All web pages basically use those. And the advantage is that you can also then describe the handling of the data and everything in R, what is close to many of us. So we go that route, and I think it was a good decision because really also in the consortia we find people who are able to help us with creating these because they know how to create the Shiny app, so we are not alone in this. And I also hope that for the future development, if somebody would like to add to this or just take over part of this, there will be some people who could do that. So, yeah, what it allows us then is to show users different interactions, show the results, show them on the map. They can change the data, they can see outputs on the plots, and pretty much everything we need we can do in the Shiny app, I believe at least. At the moment there are 2 public PDTs already ready, or others are in development. So when you go to the app.biodt.eu, you can get there, and please don't go there all at once after this session because it will break. Current solution and deployment is not so good and cannot scale well. We are working on transitioning it to better solution that will scale much better, but that will take, I guess, several months to do this transition. Anyway, on the left side of the slide, you can see now this example from our prime, or the first prototype digital twins. That was the honeybee simulations. I guess you cannot see it that well on this picture, but basically there is a map. On that map you can see the land use on the Germany. So this map is for the Germany. Right now this is kind of static, but we hope to make it more dynamic in the future, that we will be compute these values elsewhere. Then you can set some parameters on that right side next to the map for the model. And underneath is the table that is actually again some input parameters for the model, where there is like how much pollen each kind of type of flowers and I don't know what else is there is producing, and pollen and nectar. So these are things that beekeepers somehow have intuition about, and they can just set all these things. They can choose a place in Germany, they can click run execution, then they wait like, I don't know, 2 minutes. And after that, they can see this output of the simulation, what is the probable survivability of the bees and how much honey and pollen they can collect in given location. We are taking the data from the German weather company for that, but in the future we would like to use data from the ECMWF, like from Destination Earth or Climate DT. And that should also give us some possibility to do predictions for the future. At least I hope so. Also, we want to do some other interfaces, for example, specialized for policymakers. There were ideas like that policymakers could come and select an area and say, okay, we cut grass here in May or March, what is better for the bees, something like that. It's a very simple thing that they really could do in the simple interface, and they could simulate this thing and have some informed decisions to do. Okay, and what are our problems right now is mostly handling all of the data transfers that I was talking about, because when you look at this picture, you can see we have some data that are going from Elter, from JB, from anywhere else. When you see down at the picture, there is the user who has his laptop, desktop, whatever. From this desktop, they are actually accessing the Shiny app that is on its own server. And if we want to show them data from the JB Elter, of course, we need to download the data to the server. And then when we want to send them for computation, we again send them on totally different server where they compute. And this is always very taxing, especially for the large data. And then there is this big question where the outputs go, because outputs of most of the simulations cannot go to the JB or Elter. They are totally different data. So we need to have some other storage for this data that will be our own. Then to add to complexity to this, as I was saying, some of these data are sensitive, so we need to have a login. And as I was saying, there was this HPC coming to mix, and HPC is very difficult to work with. For that, we have this Lexis platform that can help us actually execute this computation on, it doesn't matter whether it's cloud or HPC, and it hides all of that complexity. Another nice thing about this is that with the Lexis, we can just add to the workflows that it automatically creates an arrow crates that will describe this execution. So we will keep to that execution where the data came from, where the data went, what are their DOIs or whatever other persistent identifiers. And everything will be very nice because we will have this trackable system of the execution and what happened. But the problem is now that Lexis needs you to, as a user, to log in. And quite often when you have some specialized data that you need to, you have other login that you need for that one. Or it might happen that if it's a sensitive data, you need to log in somewhere else. So there's numerous numbers of logins that you might need, and it's very difficult to get them all together. So these are some of the challenges we are taking into account. And also for the future, when the people start using it, we also don't want to download all of the data again and again. So we are thinking of adding here this small thing that will be like the smart cache that always stores some of the data that are used a lot by the user, so we do not just download them again and again. So these are the things we are solving. To be honest, I think we are on a good way to solving most of them. For now, I don't have the best answer for how we will take care of all of the possible logins for the users, because I would like for users to have really good experience using this interface, and they could do just one login and all of the logins will somehow be connected in the background. They do not need to care about it. But we will see how we manage with that. There are technical solutions for that, such as vaults for login. So maybe that will be one of the things that we look into. Anyway, the current state right now is we have those first two prototypes, digital twins, ready. We have most of the individual components are ready, and the challenges right now are putting everything together. It might sound very easy, but actually, as you see, for example, those puzzles on the right, when you start putting it together and you just force it because they are not the same and they don't fit, it will not work. So we need to find the right pieces. And right now we are working on that integration to Lexis. Actually, we are like 90% solved this, so I'm glad for that. Next thing is figuring out how we put everything together also with the fair layer of the technical architecture, and also the last thing is then the catching mechanism. So thank you for your attention.
There's a question online. How about single sign-on doesn't work for all of these?
Yeah, that's possible, but it still sometimes may not work. And of course, you need to federate the services anyway, you know, because usually, at least, okay, I'm not that well know on the security aspects, but as I understand, usually you single sign-on to one of the services, but then still to use the other service, they still need to know about themselves somehow.
I have probably a naive question. What's the difference of digital twins from, let's say, the standard ecological modeling practices which existed maybe for 30 years? What's the new thing in this concept?
Okay.
Maybe to Dmitry also.
Yeah, maybe Dmitry helps me then. I don't know 30 years of these practices, to be honest. Yeah, but for me, here, what we are trying to achieve is that we are really creating these workflows directly from the databases to the user, without the user needing going through all of the difficult process of getting the data pre-processed right for the model, and then executing the model. We are trying to ease all of these and hide all of this complexity to them, so they still can interact with these, and you know, kind of we are enabling them to make using these models and digital twins to somehow improve their research.
Well, I think I can add a little bit of analogy here. A lot of work at Tadwake and a lot of work as modeling is like driving the cars in the early days of automobiles. Everybody is supposed to be a mechanic. You open the boot of your car and you know what's inside, how engine works, how to fix it on the road. And that's not the case anymore. And so what we're moving here is we're trying to build the solutions that simply works, they simply drive. There are still blueprints and all the owner manuals and all the documentation available for those mechanically minded ones, but a lot of the potential users of these twins are not. And they will not talk Darwin Core ever, but they will benefit from the end solution, which is based on the dynamic data flows.
Thank you, Tomas. Yes, we'll move on to the next session where we'll get a little bit more detail on one of the use cases from Claus.
Yeah, hi. Thank you very much for having me. I'm Claus from Senckenberg. I will present shared work today on the data space integration for Agrobiodiversity digital twins. The data space integration part is done from my team at Senckenberg, and all credits for the Agrobiodiversity digital twin itself, the corporate relative digital twin already mentioned, goes to the team from Dag Andresen and from the University of Oslo. Dag is also online to answer any question on this. Before I start a little bit or get deeper into the digital twins, a little bit of context. I mean, we're observing ongoing the transformation of geobiodiversity data providers continuously and increasingly into hubs of digital knowledge. This transformation is further embedded in the setup of large-scale digitization infrastructure, notably the DISCO initiative in Europe, as well as the upcoming Biodiversity Meets Data project. And these projects aim to represent the physical specimen, material sample occurrences, also in the digital domain. The tool we develop in particular in DISCO for this is the digital specimen shown here as a blue box in the lower left side. And the aim of the digital specimen is to build a representation of the physical specimen and all its relations, derived materials as samples, as well as operation semantics in cyberspace. The further objective is to foster autonomously processing of this digital item by machines, for example, here shown as trait extraction. And what we want to do with that in wider context is mobilize geo and biodiversity data in form of digital specimens, which are processed for large prognosis infrastructure currently set up in the EU and worldwide. These prognosis infrastructures are called data spaces, and what we want to do is to add value to them by providing traits, occurrences, phenology, or omics data from our collection. What the data spaces get in return back, Wouter talked about this in his talk in the bicycle session, is traceability back to the physical specimen in our collection, so you can always go back to hard scientific evidence in form of a collection object. Having a closer look to these data spaces, then is the major purpose to enable secure and reliable data processing and sharing across different domains. These domains in the EU context are called sectors. There are 14 from them. I just have them in the figure on the left side here. I don't go into detail, but this is a place where everything comes together. And one of particular interest in our context is the one supporting the European environmental policy, aiming for a carbon neutral continent by 2050, called Green Deal. And this data space is set up in the context of the aforementioned Destination Earth initiative. Destination Earth at all, not biodiversity, digital twin only, aim to set up this highly accurate digital model of the Earth. You can call it replicas. That was the aim of your question, I think. What is a particular component of the Destination Earth data space is DEDL, the Destination Earth Data Lake. Sorry for the lot of acronyms. This component here is in its layer structure shown here in the middle, and it should guarantee near data processing on the complete portfolio by Destination Earth. I must say, in the decision behind Destination Earth are the major Earth observation agencies in Europe, the European Space Agency, ESA, ECMWF already mentioned, which provides a vessel prognosis, and EUMETSAT, which distributes the satellite data products. And the idea is to do computation on high-performance system, as Thomas outlined, on this data portfolio. The data portfolio itself is mostly satellite data from the Sentinel missions, the Copernicus packages, and of course the output of the digital twins. And to the question of Lubro about what is really new in that, I think my last item here on this slide speaks a little to this. Was this also a specific component is the digital twin engine set up in the context of Destination Earth, which is a kind of game engine which enables you to orchestrate the digital twins. Of course, digital twins have existed before and will exist aside, of course, from BioDT and Destiny. But what makes this project special, I think, is that you can really let them interplay with each other. So, for example, the climate adaptation digital twin, already mentioned by Thomas, can pass its scenarios directly into the crop wild relative digital twin and compute, for example, scenarios in the context of SDG topic grand challenge questions. Looking a bit closer to the crop wild relative digital twin, and again, all credits in this respect and props go to the UIO team. I was not personally, or my team was not involved in developing this. That's all Desalin Chala and Dek Andresen. So I give just an overview because we use this in context of the data integration here. As a use case, it aims to facilitate the search for germplasms of interest from crop wild relatives and underutilized plants to improve domesticated crops. So breeders get hints what crop wild relatives might be useful to breed into the line of an already domestic crop, which will no longer, under probably changed climate conditions, perform well. Just a very high-level overview on the model is shown here. It takes species occurrence data from GBIF, combines it with climate data, soil, moisture, and so on from the Copernicus data, in particular the ERA 5 dataset, which contains to some extent also model data. It does run a high advanced species distribution model on it called ModGP and developed by Desalin Chala, outlined in one of the articles of the special issues Dmitry already introduced, and compute a germplasm distribution in form of so-called habitat suitability maps. And these suitability maps then give breeders hints where a particular germplasm might perform in a plant well. That's the aim of this twin. There is more information. Dmitry already showed this, of course, on the BioDT portal site on the prototype digital twins. I can skip this with regard to time and focus now on the implementation concept, how we want to integrate this in the destination Earth data lake. We have a pilot with the already mentioned UMatsat institution to do this together with UIO, and we built a lightweight prototype service with a front and back end just to deploy it in the EDL, very simple. We leverage, as I mentioned before, on machine actionable knowledge units, very similar to the digital specimen, but now comprising not specimen data, but the workflow data computed on a genus of crop-wild relative. Mostly we take chickpea, latirus here, grass pea, and feeds this into the destination Earth platform. You see the knowledge unit on the very left, comprising just everything which we need to run ModGP without the data, of course, code, workflow, environmental parameters, and additional parameters. This is passed to the workflow service existing in DEDL. From there, it accesses either via proxies or via download the species occurrence data from GBIF, combines it with the ARA5 data, which lives there in the data platform, as I outlined already, does a computation and pushes it forward to a digital object repository. This digital object repository is the backend we're developing as the main product of this use case. It leverages on the middleware for managing digital object at scale called Cordra from CNRI. We also use it in other contexts such as the DISCO initiative. And there the digital object lives in the form shown here on the right side. We reproduce and update the original workflow hour crate. We put some additional data on it, provenance data and research output, and add in addition, a very lightweight front end on top of it. Not as complex what Tomas showed with our Shiny interface, which allow you to steer the twin just enough to visualize the digital object. We do this to make this RO crate, which is by now only the container, so the blue box I showed before, to add a fair layer on it of machine interpretable links on the web. And this is called fair signposting. I will show a results slide very soon where you can see what this is. Coming to the results section, these are my last slides. This is just the interface built from the RO crate. You see there is nothing new, just what was already contained in the digital object. You have the section of the workflow RO crate here in the upper part. Then coming to what is added, the blue parts on the last slide, the provenance and so added here. There are several buttons already in this lightweight interface. This is computed for the full run of the whole workflow. It comprises data of 150 species in the case of latirus. And you can download several serializations as RO crate or other types, and you have a blue button here, which enables you to resubmit the workflow. Further down here, you will also see a linked data representation. I skipped this with regard to time. What I can't see, of course, is the machine interpretable layer added by this fair signposting, which is used by machines to autonomously process this. But it can be made visible with a tool called signposting sniffer, which reads the header served parallel with this web page for the user. And when you make this visible, you can see these machine actionable links here. For example, the link relation type author linking to an ORCID, the link relation type license linking to a SPDX license, here a Creative Commons license, and a link described by this RO crate. And my very last slide shows you the workflow RO crate. This workflow RO crate, the black part of the box I showed before, can be extracted and then resubmitted, edited. And this is what we propose as or suggest as an persistence and sustainability path for the digital twins to live beyond the time of the biodiversity digital twin project, which will end very soon. So this might be a migration part to the destination Earth core infrastructure. Thank you very much.
Yes, we have a couple minutes for questions. Nope. Okay, I don't see any questions online. Okay, if not, then yeah, we'll move on to the next slide, the next presentation. Okay, so yeah, next speaker is me. My name is Sharif from Naturalis, and I'll be talking about data standards and FAIR principles, and of course I'll talk a lot about BioDT, but also there's another project for the ocean digital twin also doing some similar things. The take-home message I want to give you guys is that, of course, there's a lot of data and technical complexity. However, if we cannot ignore data standards and FAIR, and I will show you why. And sort of we need to pay attention to this more carefully. And this also, I think, important for all the AI stuff we heard, because sometimes we get too much excited about the new technology and ignore the foundation. So that's kind of what I want to emphasize in my talk. So you heard the definition, but I want to boil it down in simpler terms. Basically, what we're doing is we are combining data and models, and this combination has to run somewhere. And of course, as you saw from Tomas, there's a lot of complication in implementation and configuration, but fundamentally, this is what we're trying to do. And because of the complexity that we're going to simulate, most of the time, it's multiple sources of data, as you saw from GBIF and ELTER and climate data and things like that. And that, of course, brings up challenges, and one of the challenges we are all familiar with in our domain is, shared terminologies and semantics. For example, habitat, location, locality. As human, maybe we know the difference, but when we try to do it in let's say, as quickly as possible in an autonomous way, machines need a little bit more context, and this is also a challenge when different domains come together. And we also need some certain metadata on a high level to describe, for example, X is weather data, Y is something else, and what is the summary of that when it comes together, and that's where Aurocrate will help. And because it's a lot of things coming together, as you saw in the puzzles, we really need to be careful about the provenance, in particular, like where data is coming from, who changed it, why, where it's going. And as you saw, ultimately, some of these tools might be used by policymakers. So they also need to kind of understand, can we trust this digital twin or not? And of course, there's a lot of discussions about the formats and the storage, but these are some of the things to kind of show that any data-intensive biodiversity research probably is dealing with this, and this is probably not unique for digital twins, but adding the complexity, it will get very messy if we don't pay attention to these things. This is another nice visual. This is also a very nice paper came out a couple of years ago that sort of describes from the ecological and biodiversity side. On the top, it's a nice example. If you think about like a weather app, which is also a nice description of digital twin. You have a model, you have a device, and you get some prediction. So we're kind of trying to do the similar things with, let's say sensor data and historical data, and run some model, and we have some users and interface. So in that way, it's very similar, but the domain knowledge is very, very important in our case. We also need specific biodiversity domain knowledge together with the data and model. Just a brief introduction. FAIR is a concept. It's not a standard, but it's a way to think about how you make your research data better. And one way you can think about it is that in your kitchen you have recipes. That's sometimes useful to use that. Let's say you want to find the ingredients. You need to find that easily, and same should be for the data. Ingredients should work well together. You don't randomly mix things for cooking. Same way, one data set needs to be compatible with another one. And you need to document the recipe, if you want to use it again for future things. And primarily, FAIR principles started for data, but what we are also seeing now, we want to use that for all the digital objects, the models and software. We also want this metadata for the software and the models that going to be using, because again, the whole idea is that to bring everything together to take the advantage of this advanced simulation. This is a favorite picture of mine. It's a famous picture, as you've seen. So sometimes I think of digital twin is on the top with the foundation of the turtles and the elephant supporting it. So those you can think of with our data standards and FAIR. So as I said, multiple data sources coming in. Models could be as simple as an equation that's taking an input, giving you an output. Sometimes, of course, models have a lot of complicated parameters. You have to do calibration and things like that. And then in the workflow, as you saw from Claus's presentation, where things come together. So it could be as simple as a script. You're running script A, giving an output, you're going to script 2. And then, of course, we want some result and prediction. Again, we want to do it as dynamically as possible for multiple use cases. So again, to highlight that this foundation is very important to have those digital twin. So I took out a simple example. It's not everything from the paper, but it's kind of gives you an idea, sometime what comes together. So for example, for some of this we can use Darwin Core and EML, but some of the data we also get from repositories that are not using standards. So that's why not all of the TADWIG standards could be useful. And not every data sources and repositories are using the same way. And each model has different requirements and sometimes some use cases with multiple models. So here you can see the complexity where different workflow needs to work together and you have certain prediction that you're waiting for. But it all depends on what's happening on the data layer as well. Again, some simple examples you're probably familiar with. For example, let's say organization A collects some data from survey. Organization B maintains environmental data, and then they probably have it in a closed database, even though we are familiar with a lot of open data sources, but still other communities not as openly sharing data, but we still want to use those data. And oftentimes we have seen what happens, let's say somebody publishes a paper and a model combines this data, but there's no documentation how to use those, and that also does not help with the reusability of that. So these are the things that we have encountered in some of our use cases, and we're also trying to create awareness to make sure people understand. Again, this is nothing unique for digital twin, but as we add these things, the complexity is getting more and more. So just a few brief things to highlight. As you saw, this Aurocrate framework, which is basically a JSON file, which is trying to do a unified metadata framework. Because all of this data are coming from different sources, we cannot combine the metadata, so we're trying to at least do some unification on the higher level. So just to remind you this, so this could be one example where we have some testing we're doing. Can we describe a digital twin in this way? For example, we need to know what the digital twin is doing, what's the model it's running, what are the data sets, what are the data sets this digital twin will use, and then hopefully all of these data sets have also proper metadata, proper identifier that you can follow along. If the digital twin has a specific workflow, for example, it's linking multiple data sets, how it's doing, if the model is executing a particular steps with a particular output. So each of these steps in the Aurocrate format we're trying to sort of capture. So basically you can take the Aurocrate package and hand it to another system so people can understand what you're doing. Some of the benefits, as I said, it's basically a JSON format. You can also use another JSON format. You can also use a schema.org, and we can also try to do mapping. But it helps with interoperability. We can try to describe different data sets and models and results together. And as I said, JSON is easily transferable, so we can send the package to another system or another digital twin engine to talk about that, to use it. And it also shows the transparency, what we're doing, different processes and details. And more, the use cases will get complicated, so we also need to be scalable. So if you are interested, please check the GitHub. There's some test cases, and also we have some examples from the different use cases. Quickly, I want to mention the other digital twin projects that I'm involved in. So this is the Digital Twin Ocean Bioflow project. So within the European Union, there's a couple projects that are particularly looking into the digital twin of ocean. This project is specifically focusing on data, and it's particularly what they're calling slipping biodiversity data, to make sure that when the data is going to the digital twin ocean, it's actually ready. So again, very similar issues. There's a lot of genomics data, biologging data, acoustic data, citizen science data. There's a lot of pipelines. They're also linking different things from different domains. So some of the issues that we talked about in BioDT will also apply here. So we are also taking their use case approach. Some of the use cases are very similar, but again, from the marine domain. Like for one of the use cases I'm working on has specific trait data from a particular marine species. So we'll try to use some of the existing databases, but again, not all the trait information are available easily. So again, the challenge is that those terms are not aligned, and then when it goes to the digital twin, it cannot do anything. So that's, again, the challenge that we're trying to figure out. So yeah, some of the upcoming tasks that we're busy with is we are trying to at least come up with the what we call auto-create profile that each use case can use, and sort of this is what we're calling the fair digital object implementation. Basically, in a simpler term, can we describe the digital twin so it's also structured and machine readable, and when it moves to a different system or different interface, the machine can figure out that, okay, this is the digital twin, this is what it's doing, and stuff like that. And in the Ocean Bioflow project, some of the use cases pointed out few missing things that already there. So we're going to work with worms and Platzi, and eModNet is one of the European ocean infrastructure, so how some of this data will flow there. And yes, so again, to highlight and remind you that the strength lies in combining the data and models, and then without the data standards and the FAIR principle, the turtle and the elephant will crumble. So we need to support them. So thank you. Okay, how are we doing on time?
There are a few things online.
Oh, okay.
Read them out. So there's a lot of excitement in the chat, and somebody says that I need a twin that can take it all in. Yes, we all need that. And the reaction from Doug was that we plan a training course, a hackathon in Lecce, Italy, in March, to teach how to build it. So I guess Lecce in March is not a bad place to be. It should be almond blossom and stuff. There is project funding to cover inside EU travels, but I think things are flexible. We can check with those sitting on the budget. We will not teach there how to build twins, so it won't be like full product course, but we'll be teaching elements of how to do the kind of the twin elements right. I think there'll be some fair session, maybe some data flow things. Maybe for Tadwig people, it's a bit primitive, but maybe if you're interested in the twin building, maybe it will be fun for you to attend, or you can at least help us spread the word. I don't think we have communications on social media yet, but just letting you know.
Yeah, just talk to one of us. We can find more information. Yeah. And the other comment was it's very important to fully represent the potential errors in models, as this could be seen as the answer. Yeah, I think that's why the provenance tracking is important. Yeah. Another question?
Thank you very much. I have a question concerning reproducibility. So if I understand correctly, one characteristic of digital twins is that data sources are dynamic and the twins update themselves. So how do you handle the temporal dimension? If you take a policy decision one day and you are held accountable 2 years in the future, by then the data sources will have changed. And how do you refer to the state of the model in the past at the point you took the decision?
Yeah, so that's why I highlighted the importance of the version of the model and the dataset version, so that we captured the snapshot. But one of the challenges that we're struggling with, it's the real time. We're also defining the real time in the use case per basis. So sometime it's not that you're clicking a button and you're getting the exact information right away. So our real time depends on specific use case, because we're at the moment the use case is bounded to a certain ecosystem. So for example, we have a use case based on a nature reserve. We have agrobiodiversity. So the time scope varies for each of these use cases, but it's a valid point. I think one way I think we were solving this is to provide enough provenance information when the data was downloaded. And we also did some survey to ask the people how what was the method of the data collection. In certain countries, they have very different ways of collecting data, so that also varies. So at the moment, I think the easy solution is to document them as detailed way as possible. So that's but there's no easy dynamic solution that can show you the gap. Yeah. If you want to, yeah, Dmitry.
Yes, I would like to draw a parallel with the data papers. For Biodiversity Data Journal, I had a case to review. I was handling editor for a manuscript which was based on iNaturalist. But then somebody was doing a flora project, and floras, if I'm not mistaken, they are time-stamped. The land changes, the flora changes, the knowledge changes. So when you publish flora, it always carries a date. So this data paper was an attempt to freeze the state of this flora progress, and the original manuscript had a DOI referring to iNaturalist, represented through GBIF, which is very dynamic. It changes every second, I believe. So like data paper loses the firm ground just exactly in the question that you asked. Like the moment you submit the manuscript, your DOI is showing something else, not what you saw. So thanks to the PenSoft flexibility and ability to accommodate more than one reference, we had DOI for the dynamic resource and the DOI for the frozen snapshot, which we dropped in Zenodo. It was difficult, maybe it is suboptimal, but it sort of solved at least that manuscript problem. And I think for policy-related twin states and decision-related, or maybe there are some legal contexts when we'll need frozen time-stamped states of the twin, we can do the same trick. Maybe there are better ideas, and we are very willing to listen to all of you. Thank you.
There's a comment online from Doug. Digital twins can also be predictive and operated with simulated synthetic input data. So that's also another option, another use case. Yeah. Yes, okay, last question.
Simple question. I want to ask about what kind of results would we get from the lots of different digital twins products. Like in my imagination, if it is for a policymaker or somebody just interested in some kind of biodiversity events, and what kind of information like graphs or some data sets I will get. I just want to I didn't see a very exact example on this presentation. Thank you.
Yeah, thank you. So if you go to the Our Shiny app, so that's at the moment is a visual, I guess, a map. So that's kind of like the output. In certain cases, it might be a specific decision that, say, somebody has to do for their pollinator planning and things like that. So it varies on the use case. So, but for the visual ones, we're trying at least to make it the output visually easy to understand for people. So the example we have now in the BioDT app, where basically you select a region in Germany, and there's some parameters, and then you click a simulation button, and that shows you the result based on the map. Or okay, yeah. Okay.
Sorry. So right now in the pollination use case, there is actually a plot output that you then can also download as CSV if you want to see the original data that were used for the plot. But yeah, it will depend on the use cases. In others, there will be, like polygons on the map, and you can download the TIFF or just the vector polygons. So yeah, it will vary.
Okay, I think we're out of time. Thank you so much, and thank you for coming. It was really great. And yep, please check out the website.
I'm making a pretty background for the picture.